Hey everybody, here's your life cycle of stars and HR Hertzsprung-Russell diagram assessment video. The Nearpod assessment is at tiny.cc Mr. W 2021-05-14. So that's the date for Friday when we did it. When you get to this screen right here, click log in, and then log in with your Pasco School District username and password. So let me type that in. Just double check that that's you. You can click yes to continue. And here we go. I'm going to go full screen so you can see it. Remember, you click these arrows here to go backwards and forwards. And if there are any notes or if you want to see something here down below, you can click down below. So here we go. Here's the instructions. Work your way through all the slides. Please make sure you answer all the questions. You may use any resources you wish. You can take this as many times as you want. Please try and put your answers in your own words. And please reach out to your teacher, Mr. Weisenfeld or Ms. West, if you have a question. Here's a poll. As the mass of stars increase the lifespan of stars, so as the mass increases, the gravity of the star and the pressure and the temperature at the core increases, and so that star will burn through its fuel quicker, and so those stars actually don't live as long. So the lifespan, how long a star is around, actually decreases as the mass increases. So here we go. We've got 1, 2, 3, 4, about 9 blanks to fill in. Here we go. All stars begin as a stellar nebula, a cloud of star-forming material. From there, a star spends most of its life as a main sequence star. After this, a star expands to form a red giant. This is from your notes in OneNote as well, and comes from the life cycle model that we had of a star. Depending on the mass of a star, remember mass matters. The fourth stage is a planetary nebula. So planetary nebula is something that comes after a stellar nebula or a supernova explosion. An average mass star will end as a white dwarf. A large mass star will end as a neutron star, and a very large mass star will end as a black hole. That's a lot of stuff that we learned, but I'm sure you can get it. 9 out of 9. Nice work. The Sun is an average mass star. This is true. VY Canis Majoris is a very large mass star. Which star would you expect to have a longer lifespan? Explain your choice. So, the Sun, our star, should have a longer lifespan. Since our Sun doesn't have as much mass as VY Canis Majoris, it has less pressure in its core and less gravity and less temperature in its core. Sorry, gotta be a stickler for spelling. All of that is due to less gravity, since the Sun has less mass. With less pressure and less temperature, the Sun goes through its fuel slower So that's that question. On the HR diagram, circle the approximate location of the sun. So that is right about here. You can circle that one since it's the brightness of one sun and a yellow star and has a temperature of about 5,500 degrees. Next question. Use an X to indicate the location of a star that is brighter and hotter than our sun. So if this is our sun right here, this isn't an X, so this doesn't count. Everything this way from our sun is hotter, and everything this way from our sun is brighter. So you could check any of these stars that's up this way. So for sure this one. But you can check anything. I mean, this one works here. It's brighter and hotter. This one works. This one works. All those are good, so you choose. During the main sequence portion of a star's life, fusion is occurring in our sun. What two elements are involved in fusion? So, hydrogen is fused in a star's core to make helium. Hydrogen and helium are involved. Can a very large mass star make heavier elements than our sun? Yes, it turns out. It's a very large mass star. Has more temperature and pressure in its core due to more gravity. Since more mass means more gravity. A very large mass star has more pressure and temperature, which is needed to combine heavier elements to make even heavier elements. Let's see, I wonder if I could say that a different way, make it more clear. How about this? It takes more pressure and temperature to combine heavier elements. Only a very large mass star has enough gravity to make more pressure and temperature, which is needed to make heavier elements. That's another way to say it. Maybe that seems more clear to you than the other one. You can choose. Alright. If you'd like to get above a level 3 on the assessment, pick a star from this list, or there's other stuff here below that, so scroll down to see the rest of the question. So if you could tell us about your star, what its luminosity or brightness is, what its temperature is, what its size and mass, and then based on all that, if you could predict what you think that star is going to end as, that'd be great. And if you got that from a website, tell us what you got that from. Wikipedia is a fine place to go. It usually has this information, and then we're asking you to pull that together based on how that star's mass compares to the sun to talk about where that star is going to end up. And once you do that, you can submit your quiz. we'll grade those and then get back to you. And if you would like to try it again, you can do that. No problem. The link, once again, to get to this assessment is tiny.cc. Mr. W 2021-05-14. And it'll let you just take it again.